Satyabama Institute of Science and Technology.
Myself Thaj Delsy, Associate Professor, Department of ECE, Satyabama Institute of Science and Technology. Now, we are going to study about the basic and very important topic, binary adder and binary subtractor. In general, three 1-bit numbers can be added by using full adder circuit. But normally for communication and other operations, we go with the data with specific length. For example, we never go with 1 bit, mostly we go with 4-bit called as nibble, 8-bit called as byte, 16-bit is word, then 32-bit double byte and etc. So, the single half adder is not enough to perform the operation on these data. So, we are going to use a parallel adder to perform binary addition, parallel subtractor for binary subtraction, and the remaining operation like a multiplication and division. So, the basic is binary adder. Now, I am going to tell about what is binary adder, how we are going to convert the basic adder as a basic binary subtractor, then how the single circuit is going to be performed both binary addition and subtraction operation. So, for that we use the basic 4-bit number, binary number. I am taking the binary number A and B. Since it is 4-bit, I am representing A with A3, A2, A1, A0 and B with B3, B2, B1, B0. Here A3 is the MSB bit, A0 is the LSB bit. Similarly, B3 is the MSB bit and B0 is the LSB bit. Now, two numbers, when we add two numbers, the first two, that is A0 plus B0, produce sum and carry. This carry is added with the next 2 bit like A1 and B1. So, when you come for this next second addition, it become a 3-bit. So, 3-bit, it's going to be performed by full adder. Again, the next bit A2 and B2 along with the carry generated in the previous bit. Likewise, the addition carries. If you see, the first two alone we are performing using 2-bit addition. But in practice, we cannot split the circuit with the first stage is half adder, the remaining all are full adder. Rather, we are going to use all the stage as a full adder, all the blocks as a full adder by taking the third, that is the carry of the first stage is equal to 0. So, in this we have the sum. So, after adding the 4-bit A and B, we are getting the sum of 4-bit from S3 to S0 and the final carry out is equal to C0. Let me consider the number 1111 and 0011. While adding the first stage, we are adding 1 plus 1, 0. It will produce carry 1, that will be carry forward to the next addition. So, 1 plus 1 plus 1 is going to be sum is 1, carry is equal to 1. Again, that is carry forward to the next one and so on. Now, just see the first stage I am adding only 1 and 1. But in order to implement the full adder circuit, I am taking the first carry is equal to 0. So, that for every stage we are using the full adder. So, for this 4-bit addition, we need 4 full adder blocks. So, this is the binary parallel adder for the 4-bit number. So, the first stage, we are taking A0, B0 as the input and it is going to be produce a sum as S0 and carry is equal to 0. So, in this, the initial carry we are taking as C0 and the remaining as the output of the carry output of the previous stage is going to be fed into the carry input of the next stage and the input is taken, again it perform the full addition, produce sum and carry, again that carry is given to the third stage, again third bit, again it added up, sum, carry. Likewise, we can get the final output as like S3, S1, S2, S0 and the final carry output is equal to C0. So, while reading this number, we can read out like C0, S3, S2, S1 and S0. So, this is parallel adder. Now, the same circuit can be modified to perform binary subtraction. So, that we call as a binary subtractor. So, normally the binary subtraction we all know the binary subtraction can be carried out through addition also because the addition rule is very easier to follow than the subtraction rule. So, we may get confused in subtraction rule even. So, we are performing a binary subtraction via binary addition. So, for that we are going to use the procedure called as a 2's complement addition method. So, binary subtraction using 2's complement method. So, normally how the 2's complement happens, we keep the first number as such, we get the 2's complement of the second number. So generally what is 2's complement? 1's complement. So we are inverting the number, then we are adding 1. So that can be performed by the binary subtractor. So here the previous full adder circuit, parallel adder circuit, we are going to implement, we are going to modify something. So I said we are going to get the 2's complement of the second number, that will be added with the first number. So we are not disturbing the first number. So the first number we are taking as such in every stage, A0, A1, A2, A3. But we need to get the second complement, 2's complement of the second number. So 1's complement plus 1. That 1's complement is taken by inverting every bit. Inverting every bit. So B0 become B0 bar, B1 become B1 bar, B2 become B2 bar, and B3 become B3 bar. Along with that, we have to add 1. That 1 I am making with the initial carry is equal to 1. So automatically this B0, B1, B2, B3 along with this initial carry is going to be produce 2's complement. So this number is added with the first number A0, A1, A2, A3. So this can be performed the full subtraction, or we can call it as a parallel subtraction. So what we did here, we modified the circuit, then it is going to be perform the binary subtraction operation. So the same circuit with some modification can be worked as a subtractor. So here one separate circuit for the full addition, one circuit for the binary subtraction. So this we have to avoid. So we are going to think of to have a general circuit, single circuit, which is going to be perform both binary addition and subtraction. So the next circuit we are going to see how the single circuit is going to be perform both binary addition and subtraction. So for that we are going to use, so the initially for binary addition, initial carry is equal to 0 and we are taking the number as such. This is the first case. The second case, for binary subtraction, the initial carry is equal to 1 and you have to complement the second number. So with that rule, we are going to use the XOR operation. So in XOR operation, we are going to use one bit as mode bit, the another bit is going to be the second number. So 0 XOR with 0. It means that if the mode operation is 0, the initial carry also 0, B XOR with 0, it's going to be produced, the output is equal to 0. Again, 0 XOR with 1, produce the result is equal to 1. So in this case, you see, if any number is XOR with 0, the result is the same number. Right. Again, if mode is equal to 1, it means if Cin is equal to 1, then XOR with 0, it is producing the complement. So number 0, but it producing the complement. And 1 XOR with 1, it producing the complement of 1. So it means that if any number is XOR with 1, it will produce the complement of that number. So with this understanding, we can say if mode is equal to 0, we can perform addition operation. The mode is equal to 1, then we can perform the subtraction operation. So again, the circuit is modified further in order to perform both binary addition and binary subtraction. So this is a circuit which is going to be perform both binary addition and subtraction. That means the single circuit can perform both binary addition and subtraction. Let me see how the operation is. So normally we know that for binary addition, initial carry should be 0 and the input, both the inputs are taken into the full adder as such. So here 0, mode 0, so initial carry is equal to 0. Now A0 is taken as such. Now 0 XOR with B0, so produce output is equal to B0. Again 0 XOR with B1, produce the output is equal to B1. Again 0 XOR with B2, produce the output is equal to B2, and 0 XOR with B3, produce the output of XOR gate is B3. So when M is equal to 0, the output of XOR gate is same as the input B0, B1, B2, B3. So automatically the circuit is going to be perform the addition operation. Now let me see how it is going to be perform the subtraction. So if M is equal to 1, so for initial carry for subtraction is going to be 1 because we are implementing the 2's complement addition. So M is equal to 1, so initial carry 1. Now this M is equal to 1 XOR with B0. So any number XOR with B0 produce a complement of that particular number. So 1 XOR with B0 produce B0 bar. Here B1 bar, B2 bar and B3 bar. So automatically what happens? It will take out the first number as such and it will take the 2's complement of the second number. So it perform the operation. So it will produce the corresponding subtraction result. So with this I can conclude the even we have a separate circuit for adder and subtractor, but with this mode selection switch and the XOR gate, we can perform both addition and subtraction by using a single circuits. Thank you.